This is topic 7-3, graphing linear equations using y equals mx plus b. Our objective today is I can graph lines using y mx plus b. So our essential question is, how can I graph lines using y equals mx plus b? This is the slope-intercept form, and so today we're going to be using the slope-intercept form in order to graph lines. Our bill work is to determine whether each graph below represents a function. To determine if a graph is a function, we're going to use the vertical line test. You can use the edge of your ID or a pencil or piece of string, and you want to do a vertical line. And you're going to take that vertical line and move it across your graph and see if that line is touching your graph in more than one spot. So we are looking to see if this red vertical line touches the graph in more than one spot. And we see that it does not touch in more than one spot. That means it's not cheating, or that means it is a function. Look at the second graph. We're going to move it across, and it's like a V opening to the right, and you will see I've now started to touch my picture in more than one spot as I move across. So this tells me my line is cheating with a point at the top and a point at the bottom. That means it is not a function. The last one, as we move across our graph that's a V opening up, you will notice that the vertical line does not touch in more than one spot. It will only touch in one spot. So that means that the last one is, yes, it is a function. Again, your vertical line acts like your x's, and you're trying to see, do you have any cheating x's? The only one that has cheating x's is our middle one, where it is touching our graph in more than one spot. So let's get started with our topic. We're going to figure out what the slope is, also known as the rate of change, and the y-intercept, and then graph it. So we're going to write some steps down that helps us out. Our equation is already in our slope-intercept form, our y equals mx plus b. So the first thing we're going to do is we are going to write y equals mx plus b either above or below your equation that's given. So the first one, I'm going to write it above, and I'm going to line up my y with the y, the equal with the equal, m, x is lined up, and then plus b. As I'm looking at it lined up, now that we have it lined up, we can figure out what our m and our b are. So we're going to get the m, which is our slope, and the b, our y-intercept. So when it's lined up, I can see that m is equal to 2. This is my slope, also known as my rate of change. When I look at it, I want it to look like a fraction, so I'm going to write it as 2 over 1. My slope is positive, and so that means the line, when I draw it, should be increasing or going upward in a positive direction. So I'm going to write myself a little cheat. The b is the number that's on the end. It says plus 4, so our b is 4. But when I graph it, I'm going to graph it as a y-intercept and graph 0, 4. Where the first number is my coordinate x, and the second number is the y coordinate. So we found our m and our b. The third step is we are going to graph it now, and we begin with the b, which is our y-axis, and then we move the point. Okay, so our beginning point is the b, and then we move the point with our m, or our slope, or the rate of change. And we always want m as a fraction. Okay, a rate of change is how it changes. So let's begin with our b, or 0, 4. Our x-coordinate is the horizontal, y-coordinate is the vertical. So 0 for the x, y is up 4. We will have a point at 0, 4. That's how we begin. Our slope is a positive 2 over 1. The top number tells us how far to go up. The bottom number tells us to the right. I know I'm going up because I'm increasing. So I'll go up 2 to the right 1, and I'll hit another point. So my point is now moving up 2 to the right 1, got another point, and up to the right one. I now have 4 points that I can draw a line between, but just to be more accurate, I'm now going to go backwards. I can even see if I drew my line, yes, it is going in an upward direction, so I did do it correctly. But let's see how it fills in the rest of the graph. We'll go down 2 to the left one. We're going to do the exact opposite to follow the pattern to get my other points. It is a good idea to draw the points throughout the graph, because when you draw your line, it may not be as straight as possible, but if you have your points, you will be able to graph correctly. And when you're graded on your beginning point, and then you're graded on your slope using the slope. The last thing that we're going to do is we're going to check our graph using the calculator. So we have an equation, y equals, that should tell us, hey, maybe my calculator could be handy. So bringing up your calculator, we'll turn it on, go to the y equal. If there's anything in there, we'll clear it out. And then we're going to type in the equation exactly how it looks. It's 2x plus 4. And hit the graph button. I am seeing a graph that is going in a positive direction, so it is increasing. I also see that looks very similar to what I have. I see that my y-intercept is somewhere above in the top, yes, and my x-intercept is somewhere on the x-axis in the negative, and that's correct too. I can't tell exactly what those points are, but it does look like what I have here, and that's what I'm looking for. Does my graph look like what the graph on the calculator looks like? And in this case, it does. So those are our steps that we're going to use in order to, whoops, sorry about that. Those are the steps that we are going to use in order to graph equations in slope-intercept form. There we go. I want to get my steps so that I can copy them to the next problem. You do not have to write them out again. You already have them written. Okay, so the first step says we're going to write y equals mx plus b across the top or down below it. Now we'll find our m and our b. My m is lined up. It's the number in front of the x. This time it's negative, so we have a negative 3/2. And the b is the number that's on the end. It's a minus 3, so our b is actually a negative 3. Writing as ordered pair, it's 0, negative 3. Since my slope is negative, this is going to tell me it's going to move my point in the downward direction because it's negative. So this time the top number tells me to go down, but the bottom number still tells me to go to the right. So as we graph, always remember, the top number will go up or down depending on if it's positive or negative, but the bottom number will always go to the right when we're graphing. So let's graph. We're going to begin at 0, negative 3. We have our point at 0, negative 3. Now from this point, we'll go down 3, 1, 2, 3, and we'll go to the right 2, 1, 2. We have a new point. From our new point, we go down 3, 1, 2, 3, go to the right 2, 1, 2. We have our new point. I can follow this pattern, go in the opposite direction in order to fill up my graph throughout the grid. In the future, we're going to be graphing several lines on one graph and trying to find out where they intersect. So it will be very important to graph throughout the entire graph. Also adding arrows to the end. Okay, last step is let's check, go to y equal. Now when I type in, I have to make sure to put my fraction in parentheses. So open parentheses, it's a negative 3 divided by 2. And when we have a negative, just always put it with the top number. Close off your parentheses, and we have our x, and then minus 3. Remember, we are just looking to see, does our graph look similar? And sure enough, it is decreasing, always going down. I see my x-intercept where it crosses the x-axis on the negative part of the x and the y-intercept on the negative part of the y. So it does look like we have the correct graph. Example number 3. Again, I'm just pasting so I have it with me. Start with writing y equals mx plus b across the top. This time the m is a negative 4. I want it to look like a fraction, so I'll put it over 1. It's negative, so that tells me I should be decreasing. So the top number is going to tell me how far to go down, bottom number always to the right. B is my y-intercept, and I'll look and there's nothing there with the B. So the number that represents nothing is 0. So my y-intercept is actually at 0, 0, or the origin. So we've got our m and our b. Now we'll graph. Let's begin with the b. The b is at 0, 0, our y-intercept. And I'm going to move this point by going down 4, 1, 2, 3, 4, and to the right 1. I have a new point. Down 4, 1, 2, 3, 4, to the right 1. Down 4, 1, 2, well, I ran out of room, so I can only put those 3. But I can go up 1, 2, 3, 4 to the left 1 in order to complete the pattern. 1, 2, 3, 4. Connect the dots. And the last thing to do is check it on the calculator. Y equals, we have a negative 4 and x, and let's see. It is decreasing, it is going through our origin, and it looks like our graph. Problem 4, we'll start off with y equals mx plus b across the top, or below it, whichever one you have the room for. This tells me my m is 5 over 3. It's positive, so that means it's increasing. That means the top number is going up, bottom number is always to the right. B in this case, notice it is a minus 4, so our B is a negative 4. As an ordered pair, we'll write it as 0, negative 4. So now we're going to graph beginning with our B. So let's go to the point 0, negative 4. Now we're going to move that point by going up 5. 1, 2, 3, 4, 5, and to the right 3. 1, 2, 3. We'll go up 5. 1, 2, 3, 4, 5, and to the right 3. 1, 2, 3. And start at the beginning, go down 5. 1, 2, 3, 4, 5, and to the left 3 in order to complete it throughout the graph. I am going in a positive direction when I read the graph left to right, so it is increasing. And we'll check our graph. It's a fraction, so use our parentheses again. 5 divided by 3 times x minus 4. Graph. And yes, it's an increasing graph. It's crossing the y-axis on the negative y's, crossing the x-axis on the positive x. Our last problem, we have, again, y equals mx plus b. Next, we're going to get our m and our b. This time for m, there's not a number in front of the x. However, if there's not a number, we know there's an understood 1. So our m is actually the 1. As a fraction, we'll write it 1 over 1. B, we have another thing where we don't have anything on the end, so our b is 0. That means it goes through the origin 0, 0. If the slope is a positive 1, that means we're going to go upward. So the top number is up 1, bottom number is to the right. Start off at our beginning point, 0, 0, and then we'll go up 1 to the right 1, up 1 to the right 1. You will notice it is on the diagonal. So let's check our graph. See if we have a graph going through the origin and increasing. So y equals x. And sure enough, we do have our graph. To do our summary, you need to put the 4 steps that we use into your own words. Some of you may not need to write the y equals mx plus b above or below it. I think it's a great idea. But when you summarize, you're putting the information you need. So in your own words, you're taking those 4 steps and putting them in your own words. You can write them as steps, or you can write them as a sentence or a paragraph. The choice is yours. So in your own words, you know we have to line up the y equals mx plus b to get your m and your b. Then you're going to graph beginning with your b or your y-intercept, and then move your point with your m. And last, we're going to check using the calculator. This concludes the topic 7-3, graphing equations of lines using y equals mx plus b.